Hello, this is Jure from the Minerva class M22. In this video, we will look at setting up the coding environment that you will use at Minerva for various purposes, including FA assignments or programming structure study session. First, we should download the package of useful data science tools called Anaconda from anaconda.com. You can find this link in video description. Then we will visit the download page, where we will scroll down, choose our operating system, Windows in this case, and download the latest Python version by clicking the download button. Installation can take up to 10 minutes, so we should wait a bit. Now we will continue through installer by pressing next button and reading license agreement. Now we recommend you to install Anaconda for all users to make your files accessible for future use. This will also prompt you for administrator access. After confirming the administrator access, the new window will pop up and you can accept the install location. From advanced option, we recommend you to add Anaconda to system path variable, so you can access your Anaconda installation from Windows command prompt. Therefore, you can quickly run your favorite application or perform advanced installation. Besides Jupyter Notebooks, Anaconda provides a full set of tools that you can use for coding. You can find more information about them in the link under this video. When your installer shows message completed, you're ready to go. You can close your installer and also the browser window. To start Jupyter Notebook, you can open Start and search for Jupyter Notebook. In case this does not appear, you can open command prompt and type Jupyter Notebook or just restart your computer. Then after launching, you should see the black command prompt window running on the background. It's super important not to close it during your whole work session with Jupyter Notebook. Jupyter Notebook will open in your default web browser. On home screen, you can see folders and files in your home directory, which have the same location and structure as in your file explorer. You can also see the main folders like Downloads, Desktop, and Documents. Use this folder to navigate to the location of your notebook file. Let's assume that I just downloaded my notebook file from the internet, and now it's in Downloads folder. Notebooks files have its own extension IPYNB, which is an acronym for IPython Notebook. You can create your own Jupyter Notebook by clicking on New, Python Free, or opening an existing notebook by clicking on File Name. This is how Jupyter Notebook looks like. The smallest and the most important component of the notebook is the cell. We recognize two main types of the cells: code, where you can type Python code and execute it, and Markdown cells that are used to write formatted text and anything you would see in normal rich text editors, including images, charts, equations, bullet points, headings. That's what makes the Jupyter Notebooks very popular in education and research. To edit a Markdown cell, double-click on the cell and you will enter to the edit mode. To get beautifully formatted text back, you have to run the cell by clicking Run button or by pressing Shift-Enter. Code cells are composed from the three areas: the input area, the display area, and the output area. Input areas contains your Python code with highlighting according to Python syntax. After you press the Run button, the cell will be executed. After you run cell, you will see the display and output areas below the cell. The difference between these two areas is subtle and sometimes it may be confusing, but it's very important in some instances. The display area is reserved for any item that code has produced for the viewing. This includes simple text like print hello world or some figures from a plot. The output area is reserved for items that cell returns. Output can be useful during testing of your code and you can also store it as a variable for later use. All code in the notebook is executed by Kernel. Kernel is a Python interpreter or console running at the background, listening for your request and returning output. The kernel is doing all the computations and keeping all the variables in the memory. Sometimes your code may need more time to compute the results. Here we can see that your kernel is busy and cannot execute other cells. Other cells are in queue and they will be executed after the cells before are executed. The cell in queue, or ones that are currently executing, are marked by an asterisk in an prompt at the left side of the cell. Now we can see that our big number is finally computed successfully, and also the cells below was executed. Let's run the remaining cell and we can go on more difficult task. There is a cell that contains the code that will never finish. It's called infinite loop. It will print hello kernel forever. So when we run it, we can see an asterisk in the square brackets next to the code cell. Also, a busy kernel is identified by a full gray circle in the top right corner of the screen. These are two main indicators that you should check if your notebook is not responding. So if you see that your code is broken and it's not going to finish in a reasonable time, you have two options. You can interrupt the kernel, which will stop the kernel very gently. Sometimes the interrupting kernel may not be effective. In that case, you should restart kernel. This will force the kernel to stop and the new kernel will be created. The problem is the new kernel does not remember any of the variables from previous session, and you should run all cells from the top except your broken log running cell that you should fix. For example, now you can see that this variable is not found, is not defined, but it was defined before, but the kernel is restarted. So you need to run all cells from the top. After we successfully run all cells, we can see that our variable is again in the kernel's memory. Kernel is really nice. It stores all the variables and objects that was creating during the session. You can also work with the objects, modify them, or delete them. Therefore, kernel can be your best friend, but you should be extra careful when you execute cells in different order. This can lead to unexpected results. For example, we run this cell in the middle. We can see that it throws an exception because we are missing some variable which is important to run this cell. When I run the cell above it, also this cell starts to work. Then I can run the cell below and update the cell value. And now I can always run the middle cell again, and we can see the value is different than it was previously. When you are reading this notebook, it can be confusing because when you go just linearly from the top to bottom, you may miss the different sequence of the numbers in the square brackets. Now you've learned how the cells work and you are ready to create your own cells. It's easy. You can just go to the top panel, choose Insert, and choose if you want to put new cell before or after the current cell. You can change the type of the cell. You can use code or Markdown. For this demo, let's use Markdown and write our first Markdown code. We will use 3 hashtags as heading of third layer, and then write our text. We can also decide to move our cell more up or down by clicking on the arrows. Sometimes, if you create too many cells, you can decide to delete them by clicking Edit and Delete Cells. Thank you for watching, and you are now ready to write your first Python code in Jupyter Notebook environment.